Welcome to a new test and teardown video. This time I am super happy to show what I just scored. An engineering sample from Euler Precision in Switzerland. And it is an active probe for 3 gigahertz. Sometimes I am lucky. And I also got the measurement report and some other documents as well. I will of course show all the sexy details in a few minutes. So as far as I can see, it works all the way from 5 kilohertz to 3 gigahertz and just a few dBs down at 3 gigahertz and all that kind of stuff. So I believe it's a high impedance active probe for measurements in all sorts of high frequency designs. It could be mixers, amplifiers, detectors, and all sorts of stuff like that. And I am actually working more and more with stuff like this, so it is perfect timing for me as well. And oh yeah, here we go. That will be some input impedance, and of course it's much higher at lower and lower frequencies. I'm not super surprised about that. So what have we got in the little package? So this being an engineering sample, of course I expect this will be a little bit different from the real product to be released any day soon, I expect. But it's definitely looking so beautiful compared to the engineering samples I make for my clients. I mean, I'm really happy about this one. This looks so much like the... Oh, here is a charge connector. So there's a battery in here. You can really feel the weight. So probably most of this is a big, recent, good sized lithium pack. And it says here this is the input MMCX-1021 1 mega ohm 3 picofarads. And here's the output, nicely held in place here, and this cable of course goes to your analyzer. And yes, I did of course take out my spectrum analyzer, so we will play with this thing. And what else have we got? A nice holder. So the idea is, I will of course try and pack this up and assemble this. I think the idea is you will hold this in place like this, and then you have your circuit on your table with as short as possible connection to the input. And of course we got all the little attachment probes and stuff like that. Probably those cables here, they will be a little bit too long for the super high frequency bands. Then I guess you can connect these directly or something like that. Yeah, let's open and inspect what we got. And a little charge cable and the power supply. Everything is here. How cool is that? So I think I passed the first little IQ test to figure out how to assemble this one. That was nice and easy. This one goes in here and then it locks into place. And you can see we got the two little lines here, so you can decide whether you want it like that or like that. It's probably because you don't want any capacitance and you don't want the input to be long. So by being able to have it like this, you can have it standing directly over your test object. So that's quite nice. I don't know if you can see this. Let's turn off the light. Can you see this? Yeah, here we go. So the lamp is going really cool color cycle like this, and it really is looking a lot like it's charging. So this is of course exactly what it is doing. I just plugged in the cable for the charger, and then it's looking like that in the most nice looking way. So this tells me it's charging. I could probably also turn it on at the same time it's charging, then it will, let's see if I can do that. So you hold this in for a second, yes, and then it goes green, and then it blinks green in the same cool dim up, dim down way. There's of course a microcontroller and all that kind of stuff in here. So I wanted to show the little probe attachments here, and if we look here at the front, we can see they made this little groove. Here you go. So there's a little groove, and this makes input of the little probe lead here really nice and easy. Let's see if I can do this without shaking too much on my fingers, like this, and then I hold here and then click. Yes, nice. And there you have it. Look how the wires or the tracks in this thin flex PCB, it goes around and around and around like this, and I believe they are making a balloon, because they keep their 50 ohms impedance, or a much higher impedance actually, right? Because it looks like very thin tracks. They're just minimizing the noise. And there's another one here where they just have parallel tracks, I believe. Yes, see, they are just parallel all the way, and there's a little resistor down here, and then you can, yeah, maybe you just cut these and solder them directly to your circuit board. I mean, of course you need to buy new ones of these once in a while when you wear these down. I don't think they will be super expensive or anything like that, but you can also make your own. See, they also got this little circuit board, and these type of connectors, they are not impossible to buy really. So I mean, there is hope. And there's also one without a connector, and then they got this little male female here where you can just solder this in and then do a little bit of plug in and out and stuff like that. So it's quite versatile, the little add-on set here. So I'm quite happy about all the little stuff that I got, and also got two little cables where I can do experiments. So, but I want to try this this one first. Definitely, it's much more fun, isn't it? So here is what I've done for my first test. I don't know if this is real easy to see, but let's try and magnify this a little bit. See, there's a SMD resistor that is loading my input so that I will have about 50 ohms. And then I got two 100K resistors forming a voltage divider. And I soldered this with tiny little wires to this test probe here. And now I'll see if I can use my tracking generator and see if I will get anything through. So here we go with my first little test. I'm still charging it a little bit, so of course it's not turned on when it's charging. I think I have everything wired up and ready. So this is my signal to the tracking generator output. And here's of course my output from my active probe. So here we can turn on and off the tracking generator. Let's just try and keep it turned off. So it is now turned off, I guess. Just one click in 1 second, and then it should go green. Yeah, here we go. So now it's turned on, and so far so good, right? So let's try and turn on the tracking generator. Doobie-dee-doop. And then we see nothing. That is not so good. So what am I doing wrong? Maybe this little resistor stuff here is not connected, but I mean, I'm doing a full sweep, so something should go here. And what if I did not connect signal and ground correctly here? That means I have a short. So that could also be a, did I click in this one all the way so it said click? I will of course double check that. But that was my first little experience. So let's look at this. So here is my tracking generator directly connected to my input, and I got about minus 30, and that's of course because my tracking generator level is minus 20, and I got a 10 dB attenuator here. So of course I think I figured this out, because I got a 50 ohm resistor here and I got 100 Ks of resistors, because this is supposed to be high impedance input and all that kind of stuff, right? So I should be able to amplify this and get it up and running. But of course, when you look at this sweep here, this is covering all the very, very high gigahertz, and the low frequency where all this high impedance is of high benefit for this measurement is so low here, you can probably not see anything. So what I could do is give it some more level, and then we should definitely get something. And here you go. Now we got a signal, and all I had to do was remove the input amplifier or input attenuation. I'm not using the preamp, and back in my tracking generator, I have now full output, and the funny frequency you see here is of course because of just those resistors hanging and dangling up in the air and all that kind of stuff. And if I touch these things here, you'll be able to see what is going on. See, I can create all sorts of resonances and all sorts of peaks and dips and funny things. How cool is that? And of course, if you want to show the full frequency sweep like they did in the manual here, like that, they are of course using what they say here, see, a 9 dB attenuator positioned close to the input, I suspect, right? So they will take the output from their analyzer and an attenuator right here in a 50 ohm environment, and that is of course how you get this nice flat response. Well, I wanted to play with the high impedance, so I think we should definitely just try and go down in frequencies and see what happens. So here is low frequency sweep. So this is from 10 kilohertz to 10 megahertz, and now my tracking generator is off. So let's try and turn this off, and here you have it. A lot of signal here at the low frequency, and you can see my noise floor is about 90-100 or something like that, right? And this is of course with this amplifier turned on. So let's try and look at that, and let's see if we can turn this off. Did that change a little bit? Could probably, didn't we see a little bit down here? Okay, so let's try and turn it on again. Yeah, here we go. So that is a little bit of noise of the amplifier, but it's really, really low. This is quite impressive. There's one funny thing I realized. See, this is my background noise. I tried to turn it on while it's running on the USB charger. Look at that. So we get all this funny looking noise. That is the USB charger affecting our measurements. And of course this USB charger is not their own design, but it's just fun to see that it's making all this noise. And if I remove the USB charger, oops, We also get a DC overload, and that is of course because this amplifier here goes all the way to DC. And I have of course an extra attenuator here in the front because I don't want to blow up my spectrum analyzer. So that sounds like something you need to worry about when you go in and out of a charger. There's a little spike or a pulse or something like that that will make your analyzer a little bit angry at you. So let's try and play with an oscilloscope instead, because if we look at the specifications for this particular active probe, it goes all the way to DC. So that is DC to 3 gigahertz of active amplified probe. So yeah, I'm a little bit impressed about that actually. So let's try and turn this on. Here you go. And this is 1 volt per division. I have probe times 1, full bandwidth, and 50 ohm load on my input here. And you see about 1 volt of 50 hertz. And that is of course because my input here is just floating connected to this. And if I touch, see, everything here goes a little bit crazy. So I should probably just try and make another little DC input here. If I remove my input, see, it is of course nice and silent. So it is just because I got everything here just hanging and dangling unshielded on the input. That will of course be amplified because it is really there, right? And here is a really fun thing that I think we should talk about. I don't know if it's easy to show both things at the same time. Let's go a little bit closer like this. So here is the probe I was using, and it had some text down here. It says output and it says ground on the other side. So ground should be this piece of metal, and I soldered a tiny little wire here. So if we take the metal on the connector like that, it should be connected to this one, but it's not. So let's try and take the metal on the connector and measure here. Oops, it's also not connected to that one. So what if we take the sensor conductor and measure that one? That is all my kilo ohms, but to ground it should have been this one. See, it's 0. Oh, look at that. Here's correct. So the sensor conductor here is connected to my signal. See? So that is correct. Oh, look at that. I found it. Up here. This connector's ground, or this metal, is not soldered. Oh, let me zoom in on this. That is so cool. So here we go. So this connector seems to be soldered on the connector, but it's not soldered to the circuit board. I don't know if this is easy to see, but here we go. Just like that. So here I took the other little input cable and this little breakout board, and I put a 50 ohm resistor like that, and of course a probe so I can see what's going on my scope. And this is 1 hertz, and my input is of course the purple one. And just to see that it is of course capable of handle really low frequencies. And here we go with 1 megahertz, exactly the same setup of course. And in this mode it's easy to see the input amplifier is of course down here, right? And I am still running on USB power. See what happens when I touch. Let's see the noise here. This is when I touch the input amplifier area, and maybe it's related to the power source. And of course I have LED lighting and all that kind of stuff in this area, so it can also be to blame for that. So let's try and crank up the frequency a little bit. And here is 10 megahertz, so let's try and go a little bit faster, 50 megahertz. And how about 100? Yeah, here you go. And you also see now my input is getting lower, and obviously it's because look at the wires. This is never gonna work for 100 megahertz. And see what happens when I just go and touch this with my fingers. See, I'm just poking around with the cables like this, put them a little bit. If you put them closer, you will get an impedance that is better. Can you see what's happening? And if I open them, I get inductance, and this way I attenuate the input. Quite easy to understand, really. So that means inductance, that means attenuation, and the closer you go, the better it will be, obviously. So I think I have reached the maximum for this kind of absolutely silly setup like that, but it's just to play with low frequencies, more or less. I think I did promise we were going to open and inspect this really cool unit. And again, when you look real nice and close to it, it is really, really a high grade of quality for a engineering sample. I mean, but yeah, let's find a little Torx and see if we can get inside. Oh, did I not unscrew it enough? I was hoping we could open it together for the first time here. Oops, here we go. Ooh, that is one big lithium cell. And oh, they even put in, see, the little brass screw inserts. I mean, this is a beautiful, beautiful design. It's okay, it's indicated here with minus and plus here on the battery holder. The only thing I would have done, if it would have been my design, I would have put a huge positive marker here and a huge negative here. I mean, of course they probably protected this in a good, safe way. Oh, it's in here. Okay, and here's exactly where you want it, because now you have the battery and you want to put it in, and then, okay, no problem. I will, of course, take back what I just said about that. So, okay. Beautiful. Of course they did. And here we go with all the different parts. And see, they did put in little brass inserts. Definitely over average for a prototype. And see this part here? This bends in and touch the little switch that's doing everything. One tiny switch doing battery level when you push it a short time when it's on, then it blinks how many percent there's left on the battery for different ranges of battery remaining. All that is really cool. So it's full of all sorts of battery management features and such. So that will be the charger, and also USB for software updates. And there's of course a little charger system for the battery in here behind this little shield. There's probably a little microcontroller, right? But I don't plan to take this off because I really, really like to keep this unit good and working. I really like they put on all this conformal coating that is really, really good. And of course, again, it is a little prototype, so they will probably fix those little wires in the next version. And here is the amplifier front end, where they're doing all the really cool things. There's probably some DC biasing or something like that, and a little op amp maybe for the biasing and stuff like that for this amplifier thing. And here we got the, there is no capacitors in this signal path because it should work all the way from DC to 3 gigahertz. So how are they doing that without a proper ground plane? Because they want really, really low picofarad. And you see here as well, they haven't got any ground underneath the front of the amplifier, but they got metal here. So that is a little bit funny. And maybe this is why this front area here is a little bit sensitive to capacitive coupling of noise, and you just don't touch it. I mean, it's not a big deal. It's just because I'm touching it just to make it do crazy things, because otherwise there's nothing to talk about if you don't do crazy things, right? And here's the output from the amplifier that goes to this connector that is our output. Here's a little debug programming, see, SVDO and the reset and VDD, and this is real nice, a connector without having a connector, so it's not costing anything, and all the signals go straight to the CPU. So yeah, definitely a really, really nice little unit. Let's see if I can figure out how to put this back together in a good way. It was the other way around, right? Easy peasy. Everything fits really good. So of course, when I'm browsing around, looking and reading the manual, of course I find this sentence: the probe was not designed to be handheld. That is of course why. I mean, what do you expect? So there's a high impedance amplifier, so it will pick up your noise from your fingers if you touch the front part of it, obviously. So, so it's of course written in the manual. And here is the block diagram of the whole unit, and it's really nicely engineered with the battery, resettable fuse, reverse polarity protection, and all this on-off and charging ICs that handles high and low current. There's a boost converter to do positive and negative supplies, and LDOs to make super nice and clean plus and minus 6 volts. And what do you know? The microcontroller even measure the positive and negative supplies and monitor this and reports via blink on the LED if there's something wrong. So that's quite fascinating. I wouldn't expect it to be that well designed, but that's how they did it. And of course you can measure all sorts of filters without loading and all those things. So I'm definitely going to find a lot of cool usage for this fantastic little unit in my workshop. So thanks a lot for the little gift. I'm happy about it.